Hello, everyone, and welcome to this webinar about the ESP32-P4 Redefining Edge Computing Performance. Once again, we have a great guest with us now. We are joined by Anant Gupta from Espressif Systems. Anant, how are you?
Yeah. Hi, Brian. I'm good. How are you?
I'm great, thank you. When I was at Electronica and Embedded World, I got to see a bit of the P4 that you were announcing. I spoke to one of your colleagues there on camera, so it looks like an exciting product. So I'm glad you could join us to tell us more about it.
Yeah, definitely. I mean, we are also excited to have it available now. And yeah, it really brings in a new game. I believe it will be a game changer.
Yeah, and everything's changing the game these days. There's so much change in AI. I mean, just this week has seen a flurry of news from DeepSeek and so on and so forth. So I'm glad you could join us in your time zone. You're in Singapore, so it's 11 p.m. there or so. So
Yeah,
thanks for joining us.
yeah, but yeah, I'm always happy to be available here and talk to people. And yeah, and Elector is especially very close to us. So yeah, thank you for
Yeah,
this opportunity. And yeah, I'm glad
great,
we are able to have this.
great partners, especially if you stay up so late for us. Let's tell the audience about the giveaway we've got. It is Espressif related. We have 5 very cool Espressif-based boards to give away. It's a WaveShare ESP32S3 Geek development board. It's a tiny USB stick that features a 1.14-inch LCD, built-in USB-A, TF card slot, Wi-Fi 2.4 gigahertz, BLE5, 16 megabytes of flash, and 2 megabytes of PS RAM. So it's perfect and versatile for IoT and embedded projects. So I'll give you the link and the giveaway code later in the show, as always. But for now, let's hear from Anant on the ESP32-P4.
Sure. Thanks, Brian. Yeah. So hello, everyone. Thank you for joining us on this webinar today. The main topics today are around ESP32-P4, its features, its capabilities from the hardware perspective, as well as what we have and offer from a development framework point of view. So we have a lot of exciting developments which we have done and SDKs which are now available on the ESP32-P4 to have different use cases like AI, HMI, audio, video, etc. So we will touch those as well. Apart from that, of course, we will deeply go into the ESP32-P4 hardware. So let's get started. So yeah, as I mentioned, we will firstly go over the ESP32-P4, a brief introduction. Then we go a bit more details about the features, the HMI capabilities, the processor capabilities, the memory architecture, also some AI capabilities, as well as security related features which we have added onto the P4. Then we will talk about the development frameworks which we have. And then if time permits, we will have a very short demo video to showcase one of the AI capabilities which we have extracted in one of the demos for P4. So yeah, so ESP32-P4, this is just an overview of what all it has. So it has AI instruction, it has a dual core, 55 GPIOs, a lot of HMI capabilities, a lot of security features. It has a very wide development community as well as some frameworks which we have introduced. It has a dedicated low power system. So just a very high overview. It has H.264 encoding in hardware. So yeah, so from the series of SoC, it has AI acceleration, high-speed memory, powerful image and video processing capabilities. From the CPU and memory point of view, it has a 32-bit RISC-V dual core running up to 400 megahertz. And then it has an LP core system, which is a 32-bit RISC-V running up to 40 megahertz. This heterogeneous architecture helps us to have a very good HP-LP combination. We could really be running at a very low power with your LP core doing the most of the monitoring. And when you really need the compute for the real edge processing, you have some AI workload or you have some video workload, you wake up the HP core. It has an on-chip memory of 768 kilobyte. It has expandable PS RAM, which can be up to 32 megabyte. So there is no shortage of memory for any of these memory-intensive applications like video processing. Sorry. From the HMI side, it has a MIPI CSI with ISP. It has a MIPI DSI for the display interface. It has capacitive touch inputs. On the acceleration side, it has an H264 accelerator which can support up to 1080p at 30 frames per second. It has a pixel processing accelerator. I will touch a bit more in details about it later. From the security point of view, it has the standard security features, which most of the Espressif products carry, like cryptographic accelerator, secure boot, flash encryption, private key protection, which is the digital signature peripheral, and then access control using PMP, which can be also broadly went into the trusted execution environment or TEE implementations. We will also cover them in a bit more details later. And then it has all standard peripherals like SDIO, UART, SPI, but also some high-speed peripherals like Ethernet, 1 GB and 1 Gbps, and USB 2.0 high-speed. That's the ESP32-P4 block diagram. As you can see, we have a well-defined HP core and a LP core system, and then we have a LP power management system, which can really help to have a battery power supply, dedicated power management unit to keep the currents low in LP cores. And then we have dedicated LP peripherals. So as I mentioned, we could actually have a complete microprocessor subsystem running with the HP core and the HP peripherals off. You can have all the monitoring and stuff during your LP, I2C, I2S, UARTs, GPIOs, and then whenever you just read the real compute and processing, you wake up the HP core system. From security, it covers mostly all of the various cryptographic accelerators which are required for a microcontroller. It has some other detailed security features which we will cover later. So that was the brief introduction about the P4. Now we would try to go into a bit more details about each and every feature. So it would cover processing, HMI, AI, security, etc. So from the processing point of view, the ESP32-P4, as I mentioned, it has a heterogeneous multi-core architecture, which basically means it has a dual-core subsystem, which is running up to 400 megahertz, and a single-core LP core, which is running at 40 megahertz. It has a 5-stage pipeline on the HP core, which really gives us a very good I would say processing capabilities. If we just look at raw core mark number for the P4, the per megahertz performance of the P4 on the core mark is around 2.7 or 2.8, if I remember correctly. And we are increasing it with every RISC-V generation. So overall, if you see from the processing capability point of view, a single, the ESP32, which was our original flagship product, had around 1,000 of raw core mark for its dual core. When we went to the ESP32 S3, we were still having the same clock speed, which was 240 megahertz, but we bettered the core mark per hertz. So basically, we improved the performance by 1.2x overall. But now when we go to ESP32-P4, we have a nearly 2x jump from the S3. We are nearly around 2,500 of raw core mark. So from the processing capabilities point of view, this guy is a beast. It can do any possible MCU processing which I can imagine right now. So it should fit into any kind of applications or projects which you have in mind. It has the standard RISC-V IMAFC architecture, and then it has a couple of custom instructions which we have added. which is the AI and DSP extension, which we call as the XAI. And then we have some custom hardware loop instructions, which we call as XHWLP, so hardware loop. Then it has 16 PMP and PMA regions. We will discuss a bit more about that in the security side when we talk about access management. But yeah, that's part of the RISC-V core architecture as well. Along with the core architecture, we also have some very efficient memory subsystem. The major chunks to it is basically it has an on-chip memory of 768 kilobyte, which is configurable as cache for the external LP core, for the external PSRAM. So when I said that, it basically means that we have a layer 2 cache as well now, which can be used as the on-chip SRAM or the cache. And then you have your PSRAM as the main memory, which is there behind that. The PSRAM itself, it can go up to 250 megahertz running in DDR mode. So that gives us a very 1 Gbps, more than 1 Gbps of throughput for the memory bandwidth. Then it has a dedicated SRAM and a ROM for the LP core subsystem as well, which is 32 kilobyte, quite reasonable. And then another major thing is that, as you can see on the memory subsystem, the LP core has access to all the memory peripherals, all of the on-chip memory, as well as the MMU to access the external memory. So LP core can actually act as the main microcontroller, and the HP core can act as an accelerator. So your main application can run on the LP core, having access to each and every peripheral on the system. And then you can enable the HP CPU just as an accelerator. So this is very, very important and very good for ultra low power use cases where you do not want to have your HP core running and all the heavy processing, waking up the dual core to just do some very minor processing. Okay. Next, we will talk about the HMI capabilities. So basically, the ESP32-P4 has an HD camera processing and encoding. So it has a 2-lane MIPI CSI with ISP, which can support up to 1080p at 30 frames per second. Additionally, which is a very important feature, I believe, is the H264 encoding in hardware. And that can do right now 1080p at 24 frames per second. Yeah. So all in all, these two combined features can help us have like a very simple IP camera running on the MCU. So you can have your MIPI stream coming in, going through the ISP, and then going into the H264 encoder. And then what we get out is the encoded video stream, and that can be streamed out directly to your servers. From the display side, we have a 2-lane MIPI DSI, which is running, which basically means it can support up to HD, which is 720p at 60 frames per second, or full HD, which is 1080p at 30 frames per second. What we have also done is we have some very interesting use cases defined there. So just with the MIPI, the long wires are not possible, right? So what we have also done is we have created a MIPI to HDMI bridge using the P4 as well. So you can actually now drive a HDMI display as well from the P4, which basically makes it much more adaptable for large screen displays. These could be used for a lot of applications and projects, like displaying advertisement ones or kiosk and other stuff. So yeah, it enables a lot of other capabilities. Apart from that, we have a couple of graphic accelerators. primarily the PPA, which is a pixel processing accelerator. So it can be used to offload functions like tilt or rotate or zoom. So all that can be handled by the PPA without involving the CPU. So all this changes on the graphics and the display can be handled offloaded. Then there is a 2D DMA, which is basically used to move the buffers around at a much better efficiency. Apart from that, we have a JPEG encoding and decoding in hardware. So basically, we can play MPEG videos on the ESP32-P4 and drive them onto the display. So all of this in hardware, and we can support up to 720p at 80 frames per second. Yeah, I think that's all from the slide. Next, we will talk briefly about the best-in-class security features which we have added onto the product. So it has all the known cryptographic accelerators like AES 128, 192, 256, RSA, HMAC, ECC. Then we have a digital signature peripheral, which is nothing but on-chip secure element kind of capabilities, which basically means it tries to protect the private key of the device without exposing it in plain text to any software. So what it does is whenever there is need of some authentication or signing, the software has to just call the digital signature peripheral APIs. The hardware will do the signing with the private key, which is stored and secure, and provide the output to the software who call the API. So it basically means you don't have to expose your private key to any software, even the highest privilege software. Then we have a key manager, which is in the P4 to manage the keys of the private keys as well as your network keys. Then we have a TRNG, we have PMP and PMA, which combine to act as the permission control for internal as well as external memories and peripherals. And then we have on-the-fly external memory encryption and decryption. A bit more about the security features. So firstly, the secure boot. So secure boot provides a device from running any unauthorized, that is unsigned code by checking that each piece of software being booted is signed. Provisions for the choice between RSA-based secure boot as well as ECDA-based secure boot. So how it works is when we come out of reset, we boot on the boot ROM, which is of course trusted and cannot be changed. And then the boot ROM will verify the primary bootloader, which will then verify the software application. So this two-stage process helps us to have this secure boot more efficient as well as easier for changes like you have an OTA, etc. External memory encryption. As I mentioned, we can do flash encryption is intended to encrypt the contents on the off-chip flash memory. And the XTS AES block will cipher mode is a 256-bit key size for flash encryption. So basically, whenever there is a read access to the flash, transparently and at runtime decrypted. So the CPU will access the cache. When there is a miss on the cache, the MMU will give an access to the external memory encrypted crypt, which is basically the XTS AES block. This guy has the eFuse access, which basically means the access to the key and some system registers for some configuration. And then it will instruct the SPI to fetch the data from the flash. Once it has the data or the block of data in its memory, it will decrypt it and then provide it to the MMU and the cache. So all this happens in runtime, all the read operations. So basically, the CPU is agnostic of whether the memory is encrypted or decrypted, but yeah, it provides us much better capability to protect the IP of the customers or IP of the application which is running on it. Then we have very interesting the access control and privilege separation, which is basically the TEE implementations which can be achieved with this. So it is hardware facilitated access permission management and privilege separation. So you could actually provide different regions in your software, which have, different privileges to your software, which are basically make them to have different access rights to different regions, and you have 16 such regions defined. So you could actually partition your peripherals and your memory into 16 different regions and give them different kind of accesses to different masters, including the CPU as well as other masters like DMA, etc. on the bus as well. So it is divided into two parts, overall the PMP and the APM. So the PMP basically manages the CPU accesses to all address spaces, and the APM handles accesses to ROM and SRAM. Right, so that's the partition. So this layered approach ensures robust access control. Apart from that, we have a lot of other peripherals. We have 55 GPIOs, which is the highest in any ESP SoC till date. We have all the standard microcontroller peripherals like SPI, I2C, I2S, UART. As I mentioned before, we have dedicated LP peripherals like SPI, UART, I2C, I2S, mailbox, GPIO. These are basically to help you have ultra low power use cases enabled, which basically mean you can do all these monitorings and some simple processing in the LP core and only need to wake up the HP core when really needed. Then we do have some high-speed interfaces like Ethernet, SDIO 3.0, and USB 2.0 high-speed. We have some miscellaneous special peripherals, which are can be used to have achieved different use cases or some different interesting implementation, like the parallel I/O, the bit scrambler, the ETM, which is an event task matrix. So this is like a very interesting peripheral. You can actually automate a lot of things using this. So you could actually trigger a back-to-back. So you could say that once my SPI completes, I do a DMA transaction, and then once that is complete, I do HDIO transfer or something like this. So it depends upon what you want to use. So you can actually use this event task matrix to cascade different tasks and create some automations on the processing in hardware. And yeah. Okay, so that was a brief about the development, the ESP32-P4 capabilities. But how do you use those capabilities? So as we are very focused on providing an open source platform for our users and community members to develop their products and projects on our hardware, we have also enabled something similar for the ESP32-P4. So ESP-IDF, of course, which is one of our most, it is the official IoT development framework from our side. So of course, the ESP-IDF supports the ESP32-P4. Those of you who don't know what is ESP-IDF, so it's a free and open sourced SDK on GitHub. Users can get the source code of almost all of the components under Apache 2 license or third-party components under a compatible license. So ESP-IDF is stable, which means it is maintained under a clear, rigorous release process, as well as some very stringent testing process, which ensures that every release is stable. And that means that once we have an official release, it means that customers or developers can actually quickly develop their products and not worry about the stability issues. Of course, it's powerful. It includes a lot of software components, including the RTOS, which is primarily free RTOS. It has all the drivers for the product. It has networking stacks, protocol implementation techniques, and a lot of resources like IDEs such as Eclipse and VS Code, which allows users to focus on business logic and quickly build complex applications. The ESP-IDF also has a lot of components as well as examples which are directly productizable. So they can be used as it is or can be used as base to start your projects. Apart from that, as I mentioned, we have some very important HMI capabilities on the ESP32-P4. So to support that, we have our HMI Smart Display support for P4 as well. So it is primarily based on LVGL GUI development, as well as also supports others like Embedded Wizard and Slint. Then we have a lot of diverse functions for the MIPI interface. So P4 integrates the JPEG hardware codec as well as the 2D DMA. So we have all those accelerations already part of this framework available. And then we have external PS RAMs to support larger buffers. So it can so sorry. So overall, it can be used to drive a lot of displays, right? Yeah. Another very interesting project which we have is the ESP-Brookesia. So it's something related to the ESP-HMI, which I just talked about, but it's more from a developer point of view. So it's a framework, it's a GUI development framework, I would say, built on LVGL for developing modern and responsive interfaces. It is designed for AIoT devices with a focus on scalability and flexibility. So what it includes is the UI core, which basically covers all the dependent libraries as well as the apps and the management of those fonts as well. And then we have some widgets, which is like app launcher and screen bar and status bar or gestures, which can help to develop some more detailed use cases. And and then what the system UIs are like already available examples. So we have something like for a phone. We also plan to develop something for a watch. So all these are going to be there. And then the user has to do is have their own style sheets and some custom UIs. And if you want some custom fonts, and you can have your own complete GUI framework. So it is high performance because it is optimized for the ESP32-P4 dual core cross-platform development. So you could actually use ESP-IDF or Arduino. So basically, it supports C++ for PC and ESP SoCs. It has pre-designed templates, so faster prototyping. And it has leverage to use the ESP32-P4's peripherals and the capabilities. Some use cases would be smart home interfaces like thermostats, controls, displays, industrial automations for real-time monitoring and control panels, some wearables and appliances as well. Okay. So this one I think is one of the most important thing which I want to talk about today is ESP-DL. So this is our deep learning library. So what we have tried to do here is we have tried to create a flow for users to map their models or port their models for inferencing onto the ESP32-P4. So what you can is you can train your neural network using any preferred deep learning framework like TensorFlow Lite or PyTorch. And then what you have to do is you have to convert those trained models into an ONNX format, which is Open Neural Network Exchange format. And once you have done that, we have provided some quantization tools and some libraries using the ESP-PPQ, which is post-training quantization for models to quantize to optimize. This is basically so that the models can fit onto the P4 memories and the architecture. Once you have done the quantization, we have some porting tools as well. So integrate this quantized ONNX model into the ESP-DL framework. So this basically uses so what it does in the background is that ESP-DL makes use of the custom vector instructions on the on the ESP32-P4. So when we use this ESP-DL framework, we can actually take the benefit of using those instructions, which basically accelerate neural network workloads like multiply and accumulate or these vector instructions, right? So once we integrate those quantized ONNX models onto the ESP-DL framework, you can deploy them and run them on the P4 to have your inferences on the edge. So just as an example, what we did, this is just to showcase an example. We have done this with other models as well. So we tried porting the MobileNet V2 on the ESP32-P4 using a ESP-DL. So of course we obtain a pre-trained model, which is of course MobileNet. So what we can do is we have to export it to ONNX. So there is a simple command to do that, which is basically torch.onnx export, and then you tell your model, and then you have some arguments for it. And once you export that, you have that model available in the ONNX format. Once you have done that, next step is to quantize the model. So here we have to use the quantize model wrapper API. So you do that, and once you have done that, you have to export that model into the ESP-DL file. So for that, you have to use the exporter API, the PFL.exporter, and this will do the export to the ESP-DL file. Once you have the exported model in the ESP-DL format, you will flash the ESP-DL model to the device memory. This is standard. And then we use the ESP-DL to load and run the inferences, which can be done using the model run, and the get outputs. So you could actually use the get outputs. So when we do the get output for the MobileNet, we can see that we have this output size, which is basically the 1000, which basically classified all the 1000 images on the MobileNet. And then we have the total amount of runtime as well as the amount of memory it takes. So we could successfully port one of the simple models there, like MobileNet V2 onto the P4. So this is from the AI and the acceleration side, but something which is very commonly talked about, or I get a lot of questions that, there is no wireless connectivity on the P4, that is like a USB for Espressif products, and this question. So just to cover that topic, we do have a lot of various ways to providing wireless connectivity to the P4. So 3 of them I have tried to list there is the ESP-80, the ESP-Hosted, as well as the ESP-XCOM. So ESP-80 is a simple solution that enables ESP32-P4 to connect with any ESP wireless module using 80 commands. So it's very basic applications which require lower resources as well as limited throughputs. But it supports all of the primary ESP SoCs. It uses a UART interface. ESP-Hosted, which is, I would say, most flexible as well as powerful way to do this is the using standard Ethernet interface, so 802.3 interface, to allow the microcontroller to manage complex processors while enhancing wireless performance. So it uses advanced Wi-Fi and BLE APIs to call. It requires some integration effort, but if you are used to running the ESP host with wireless capability, so you can actually call the same API as you would have called on other ESP32 or ESP32S3 or other Espressif products, and the ESP hosted on the ESP-P4 can actually manage to call those APIs in the background in the hosted mode. So your application development is actually becomes agnostic. So if you have something on the ESP32S3 and you want to port it to the P4 plus C6 or P4 plus C5 with the hosted connectivity, you can do it streamlined, because we try to use the same APIs across. The other thing is you can actually also make use of the coprocessor capabilities. Basically, you have the full source code in open source for the hosted side as well. So you can actually make use of the other peripherals of the hosted device if you have some use cases there. It can go up to 70 Mbps in throughput. So primarily we focus right now on C2, C3, and C6, and then C5 in future to provide this capabilities on the hosted side. Last but not the least, we have the XCon. So this is like a pure, I would say, RCP kind of application for the hosted. So this is an extensible solution using Wi-Fi APIs directly. So if you have any Wi-Fi APIs or Bluetooth connectivity, you just call them, and it provides you wireless.
You want to grab a drink of water, Anant?
Yeah, I believe so. Thank you.
I'll just say hello to some people joining us from around the world again, from Belgium, from Sri Lanka on vacation, from Graz in Austria. What's going on? So thanks everyone for joining us, me and Anant, and also say a special thanks to Anant for joining us. It's almost midnight where he is, so continue.
Okay, thank you, Brian. Yeah. So the ESP XCon also can provide you very high data throughputs, but of course there is no configurability on the coprocessor side, and also it only supports right now on the ASP8689, which is just one of the products which we have. So yeah. Just a bit more on the ESP hosted. So it's open source using Espressif chipsets as communication coprocessors, providing Wi-Fi and Bluetooth connectivity to host microcontrollers. You can have configurable like SPI, SDIO, or even UART connectivity. So below I try to showcase a table which gives a brief idea. This table is using the P4 plus C6. And run over different interfaces. So if you use a standard SPI, which uses 6 pins, it is a full duplex mode. We can get up to 24 Mbps on the UDP and 25 Mbps or 22 Mbps on the TCP. Similarly, if you use a dual SPI, we can increase that UDP to go up to 32. On a quad SPI, we are 41 Mbps, whereas if you use an SDIO, we can go nearly up to 80 Mbps on the UDP and 50 plus Mbps on the TCP. With the UART, we are below Mbps range, which is expected because, of course, the UART has a lot of overheads to run, and it's a slow interface inherently, right? So yeah, the key advantages, you have complete control, so full access of the coprocessor resources. It has a standard interface, like I mentioned, it uses the common 802.3 interface for any microcontroller connectivity. And if you are using an ESP host, then basically you use the same APIs as the ESP MCU with a wireless connectivity. So it basically makes your development agnostic and easy to use. So yeah, I think that's all I had. We have a small video which I will just run. It's just like 30 seconds, which we try to showcase. So what we have done here is try to run an person detection or a pedestrian detection algorithm on the P4, which is running totally on the edge. It takes the input from the P4 camera using the ISP, and then it does this processing on the P4 to detect the capabilities of detect if there is a human present there on the screen, and then we display that on the P4 screen. We just have recorded this P4 screen there, so you will just see that. So this is one of our colleagues in Shanghai who's there. So you can see there is a red circle around him. Whenever he stretches his arm, that increases. He sits down. When he goes out, it's gone, right? So yeah. So that was the quick demo from our side. And yeah, I think that's all from the presentation. Now, I believe
great.
we will have lots of questions.
We do have lots of questions, and as I promised, I'll tell you more about the giveaway later. Let's get that screen up. That's the competition we're running, and all you have to do is enter the code word to win one of 5. Let me show you the product. I really want one of these myself. An ESP32-S3 Geek board made by Waveshare, and it plugs into your USB, and it even has a little display and a little card reader, so that looks like they will be fun to play with. And we've got 5 of them to give away, so the code word will be simply P4 today. So yeah, good luck with that, audience. I know you've been begging for that code word in the chat. And Anant, you mentioned that this board is the first one not to have wireless capability, although it has Ethernet. Have any of your previous boards had Ethernet?
Yeah, our classic ESP32 that also has the Ethernet interface. So this is the second product.
Okay, great. And it's for industrial environments, so I imagine Ethernet is quite a popular addition in those environments where you don't want noisy Wi-Fi, busy Wi-Fi networks all the time.
Yeah.
Here's a question for you from Adam. Will the ESP32-P4 be available as a module? Like for the S3, you have the ESP32 S3W Room 1.
No. So the primary advantage which we get when using the modules is basically the design of the wireless PCB antenna and the certification from the various authorities like FCC and CE. So as I mentioned, the P4 inherently doesn't have any wireless connectivity, so it really doesn't require to have this FCC and CE certifications to go along with it. So we really don't see any major reason for us to have the modules for the P4. Having said that, the P4 will come in SIP, which is like system in package options, which will have the PSRAM in the package itself, so it will be closely, but you would still need to have an external flash onto your boards. So the P4 will only ship as SoCs as of now.
Okay, and you decided to dedicate yourself to RISC-V on that one, whereas some of your competitors have put like 2 RISC-V cores and 2 ARM cores on a chip. What made you to decide to go RISC-V only?
Yeah, so I think that has been our direction since maybe now at least 3 or 4 years. So we have focused primarily on developing our own RISC-V core. And just to give you some perspective about that, so when we first released the RISC-V core on the ESP32C3, that was the first product which we have the RISC-V, our core mark was around 2.3. Core mark per hertz. which is equivalent to the core mark per hertz which we had with the Extensa, or slightly lower. The Extensa has around 2.4 or 2.5. But with the latest generation of the RISC-V core, which we are going to release with the ESP32-C5, we have improved that number to 3.3. So which basically means with our own IP, we can actually do much better hertz processing per hertz and provide much more powerful capabilities to our users. And that's why I think we have stuck to it, and it's being, I would say, accepted widely. The other part I would say is that the ESP-IDF handles or takes care of all the tooling and whatever is required. So from an end user perspective, it really doesn't matter whether there is a RISC-V or an Extensor or an ARM behind it. So you have to code in C or Rust
Developing
now.
environment.
Yeah.
That always helps. I have a lot of questions, but I should give the audience a chance. Comment from Paul. Can see the potential for the ESP32 in simple game dev for Steam programs. Yeah, I guess so. I mean, you've got some very good video and graphical capabilities on that system. You've mentioned 80 frames per second, 720p for JPEG. Is that encoding?
Yeah, that is encoding.
If I may ask, why would you need to encode 80 JPEG frames a second? What would your application for that be?
I mean, it could be like compressing videos and stuff like this, or compressing images, which we are receiving. So yeah.
That's fast, 80 frames a second.
Yeah.
Question here from
just
Adam.
to highlight that, sorry, we do have some engineers who write to play around, and they have like ported Doom and other video games onto the P4. So we do have sometimes party in the office where we play our video games on the P4.
That's nice. You, as they say, you eat your own dog food, test your own products, and play with them and enjoy them.
Yeah.
Adam wants to know if there are any examples of PPA on P4. Do you know of any framework that makes use of it?
Yeah, so as I mentioned, the ESP-Brookesia, it already uses the PPA for the P4. So the tilt, rotates, all these very common applications, the PPA can be invoked, and the ESP-Brookesia is already using the advantage of this one. I believe the other common frameworks like LVGL and Slint, Embedded Wizard, they are also planning to release support soon, and they will also be making use of both the 2D DMA as well as the PPA on the P4.
Great. And then the number of GPIOs, did you have a lot of demand for that in industry to have that many GPIOs, 55?
Yeah, that's correct, right? So we had that question a lot. So people always said that they are short of GPIOs for some of the industrial applications, for sure, where they have so many interfaces, so many things to monitor, and so many sensors put. So they use GPIO expanders to still continue using our microcontrollers. So we thought that, of course, then we should try to cater to people and this demand which we have. So we have increased, but I believe there will be still a lot of applications which will still be not demand for more. So yeah, so this is always an ongoing feedback.
Well, in line with the next question I'll put up, I just want to know, how long did it take you when you decided to build this thing? How many months or years of development was it?
Sorry if I understand it correctly. The question is about how long did it take for the P4 to develop?
Yeah, from idea to production.
That would be, so it's tough to say. So we have a very different kind of a philosophy in Espressif, right? So we try to see, so anyone who has an idea can actually start their own project kind of stuff, even for hardware projects. So we do have people building some IPs, so like the PPA or the H.264 encoder and all this stuff. And then when we find a suitable project to integrate them, we do that. So it's very tough for me to say when the P4 got conceptualized as it is today. It would be very late in the game. But having said that, the original plan to have like microcontroller without wireless connectivity, it would be like maybe a couple of years ago. So yeah, so it did take some time. And of course, we have been overly cautious as well to make it GA, because we want to be extra careful and certain that the things are working as we expect them to before making it available.
Yeah, I mean, it's serious business, the industry that you're going into, but it's related to my question from Waldo. Says, is ESP32-P4 already becoming mainstream? I picked STM32 because it was taking too long. Only sample boards are around, but only one per user from Olimix, for example, and this guy has 700 customers.
Yeah. So the P4 is sampling now already, so it is not in mass production yet, but it would go into mass production next quarter. So it should be somewhere in April, May. So if you already have a project which you have some requirements about, you can write us to it from our website or some other channels, and we can help to provide you samples to start development, and then we can support your requirements as they grow.
And are there any early adopters that are already using sample P4s?
Oh yeah,
kind of beta testing.
Yes, of course. Not beta testing. People are already really going for their final products. So they are just waiting for MP chips. So they have already started development for their products with the samples. And so the samples right now are MP chip samples. So they are as good as the final chip. So yeah.
Well, related to that again, is the ESP34 looks very interesting. Now we just need some products with ESP32-P4 in the Elektor store. Yes, indeed. And as Anant said, next quarter we will take a closer look at that. And I see, Anant, it's time to wish you a happy Friday, since it's
Thank you.
midnight where you are. So we should wrap it up. I think maybe just a couple of short questions, unless you want to crash immediately. What is the situation with support for Zephyr real-time RTOS?
Sure. So we do see a very strong demand for Zephyr RTOS, and we have already started supporting it in our products. So the ESP32S3, the ESP32C3, and now the C6 are already now supported on the Zephyr. So of course the P4 will also be supported on the Zephyr platform, so that will come. It's not there yet, but as for all other products as well, we will first do the ESP-IDF and the FreeRTOS, and then we will do the Arduino as well as the FireRTOS later.
Okay, great. There's a question here about LVDS video signals. Any plan around LVDS video signal and mass production availability?
The mass production, I'm not very sure about the LVDS signal question, so I would not be able to give a very definite answer there. Apologies for that. The mass production availability, as I mentioned, would be Q2 this year, so look out for us in April, May timeframe.
Okay, and there was a question about documentation. I Googled it. There, that's the question. And I will just put that in the chat. I found a good page on the Espressif website. Thanks, Anant. There are a lot of other pages, but that's a good start.
Yeah, and there are a lot of other, I would say, we already have a few blogs about it. We have a couple of articles in the Elektor magazine as well, which talk in depth about the P4. So yeah, but yeah, we will have the documentation. If you are looking for a data sheet, to contact our sales teams, and they will help you provide that as well.
Great. Won't keep you much longer. There are just so many questions. There's over 200 people watching, so there's great interest in this. I'd like to answer as many people as I can. From Instagram, which IDE do you use for ESP32S3?
Okay. So personally, I don't use an IDE. I prefer to go using the terminal with the ESP IDF. But we do support the Espressif IDE as well as the VS Code extension, and both of them are pretty mature. So if you are comfortable using an Eclipse-based IDE, you could use the Espressif IDE, or if you're comfortable with the VS Code, you can use the VS Code. We also have the Arduino IDE as well support there, but I will recommend it only for prototyping and not go for mass production using them. But yeah, so all 4 options are available for you.
Great. And Jorgen's excited about this, says, excellent, thank you. Will there be a dev kit like the ESP32S3 dev kit C?
So we will have a dev kit, which is the ESP32-P4 EV board. So it's in a different form factor, not like the dev kit C. We might also have another board, which would be maybe a slightly smaller form factor, but we are not sure about exact configuration about it. But we do have the P4 EV board available. We can share the link later. So that would be the primary development board.
And then, quick, okay, we'll make this the last one, then we'll let you go. How about power consumption when compared to the S3?
Sure. So of course we have tried to optimize the power numbers. So it's not an apple-to-apple comparison, honestly, to compare it with the S3, because S3 has a lot of wireless capabilities which consume a lot of current. So just doing like modem off scenarios, which would be basically normal run and idle modes. The P4 has more optimized current consumptions, especially on the LP core side. We have a dedicated LP CPU, which is dedicated to run low power applications.
Okay, great. Well, thanks, Anant, for staying so long. We went a bit over time, but we could have done 2 hours easily, or maybe even more. Very interesting product, but I wouldn't want to keep you until 1 o'clock in the morning where you are. So I'd like to say thanks to the audience for joining us all around the world. Reminder of our giveaway, which I put on the screen. We've got 5 of these to give away. Bring it up. Okay, so it's a great development board. It is Espressif based, but it's built by Waveshare. And the code word you need is there on the screen. There's the URL, and the code word is P4. Nice and simple. Keep it simple, hard to forget that one. Thanks again, everyone from around the world, whether it's early or late or the middle of the day. And especially thanks to Anant for taking this time. We could have done an earlier show, but they don't work as well, we found. So you joined us on our terms and stayed awake late. So thank you for that.
Yeah, thank you. No problem. Thank you, everyone. It was a pleasure to connect with everyone. Thank you so much, Brian.
Thanks, Anant. Goodbye, everyone.